Now you know everything there is to know about logs because you watched that awesome video like over and over and over because it was so great. So here's a foldable. If you want, you can print it. I gave you the file, or you can just write it down in your own notes. So logarithm is just a special way to ask a specific question. So let's first write log form. So we have log base b of a equals x. That's basic logarithmic form. So what question does this answer? Well, logarithm form, or logarithms in general, answer the question, what exponent do I need on b, I can't write as fast as I can talk, to get to a? So basically we're saying, what exponent should I put on b to get a? And that's going to be the answer. And if you think about our song, a log is just an exponent, an exponent. A log is just an exponent. Okay, anyway. Logs are simply exponents. It's great, isn't it? It's going to be in your head forever. Okay. So basically a log is just a way to rearrange an exponential form so that we can solve for an exponent. So exponential form looks like this. Let me see if I can get my colors straight. Base to the exponent equals the argument, because remember that's what's argument is inside. I think I spelled that wrong. Argument is inside the log. So that's part of our song too. The thing inside the log is called the argument. Yes, the argument. Don't start an argument. And the answer to a log is an exponent. Okay, so let's rewrite this. Base to the exponent equals the argument. This is our exponential form that we've been using this whole time. Okay, so log form is not too much different. It's log base, whatever the base is, so it's like log base 3 of the argument equals the exponent. So if we want to find the exponent, we can switch it around to logs, and the log will tell us what our exponent is. Now our exponent's all by itself. That's like the whole point of the log. Okay, so what I want you to remember about logs, the two main things is, what exponent do I need on b to get a? And then the answer to a log is an exponent. Yes, an exponent. That's what it is. I can sing the song more if you'd like. All right, so inside the foldable, we're going to practice changing logs into exponential form and solving them. So first things first, here's a log. It has a base of 4. It has an argument of 64. So base of 4, argument of 64. So we're going to say 4 to what exponent equals 64, right? Because a log is just the exponent. So the answer to a log is an exponent. So if I say, what is log base 4 of 64, I'm looking for what exponent do I need to put on b to get to a. So what exponent do I need to put on 4 to get to 64? Well, that would be 3. So the answer to a log is an exponent. So x equals 3. So for this one, 6 to the what equals 216. Again, the answer to the log is the exponent. So what exponent do I need? Well, in this case, I also need 3. 6 to the third equals 216. So this is asking 4 to the what equals 16. That's x equals 2. I'm just switching it around. I'm saying base to the exponent equals the argument. Remember, this is my argument. So again, base to the exponent equals the argument. So base to the exponent equals the argument, 1 over 243. So 3 to what equals 1 over 243? So the first thing you might notice is that it's a fraction. So that makes you think, ding, ding, ding. This is a negative exponent, right? Negative exponents spit out fractions. So 3 to the what equals 243? Is it 5? No. Is it 6? Let's pull up our calculator. 3 to the 6th. Oh, I gotta get out of the table. 3 to the 6th. Oh my goodness. Goodness gracious, it's amateur hour in here. Okay, 3 to the 6th is 729. Is it 3 to the 5th? It is 3 to the 5th. I was thinking it was 3 to the 5th and then I got confused with myself. Okay, it's 3 to the 5th, which is 243. So 3 to the 5th equals 243. So how would we make that 1 over 243? Well, that would be the same as 1 over 3 to the 5th, right? And what does that look like as an exponent? Well, that's 3 to the negative 5th gives us 1 over 3 to the 5th. So our exponent is -5, because the answer to our log is the exponent. So this would be the base is 5 to the exponent, which we don't know, equals the argument, which is 125. What 5 to what equals 125? That would be x equals 3. This is 2 to the what equals 4. That would be 2. Ooh, this one's tricky. 343, let's write that up higher so we have more room. 343 to the what equals 7. Ooh, I don't know, because it's not a fraction, so this isn't a negative exponent, right? This isn't like, oh, well, 3 to the negative, or 343 to the negative 1, because 343 to the negative 1 would give us 1 over 343. And we don't need a fraction, we just need a number that's smaller than 343. So what if I just wrote 343 in terms of 7. 343 is the same as 7 cubed, okay? So I can just replace 343 with 7 cubed. Now, on this side, on the left side, I have 7 cubed to the x, and so I know my exponent rules tell me that 7 to the 3x equals 7. Okay, so 7 to the 3x has to equal 7. That means 3x has to equal 1, right? 3 times something has to equal 1. So what does that x have to be so that it equals 1? This is like the Dora the Explorer moment. What exponent do we need to equal 1? So x has to be 1/3, right? X equals 1/3, because if I multiply 3 by 1/3, the 3's are going to cancel out. I'm going to end up with 1. So in this case, log base 343 of 7 is 1/3. So 2 to the what equals 16? Well, that is x equals 4. Okay, 64 to the what equals 4. This is like the last one. Let's rewrite 64 as 4 cubed to the x equals 4. We just replaced 64 with 4 cubed because they're equal to each other. We can replace them at any point. So this is 4 to the 3x equals 4. So what does x have to equal? Well, in this case, it also has to equal 1/3. And this 6 to the what equals 1 over 216. Now, since this is a fraction, we know this is going to be a negative exponent. So 6 to the 3rd equals 216. So 6 to the negative 3rd would equal 1 over 216. So, in this case, x equals -3. The next page of your foldable just asks you to convert back and forth. It has 2 variables, so we're not actually solving for any numbers. We're just converting back and forth. So we're going to find the base, the exponent, and the argument. So we start with log base, log base 1/5 of the argument equals the exponent, because the answer to a log is an exponent. So let's rearrange this one again. This one is in a log form, so we have the base to the exponent equals the argument. This one would be log base 9 of x equals y, because the answer to a log is an exponent. So the exponent should be the answer. This would be 7/4. What is the exponent? Well, it's the answer to that log, which is y, and that equals x. This would be log base 6 of x equals y. This would be u to the -16th equals v. This would be log base b of 123 equals a, because the answer to a log is an exponent. You're going to get so sick of hearing me say that, but logs confuse so many people, and they're not actually that hard. It's just rearranging an exponential function, and they're actually really kind of fun. I know, you hate it when I say things are fun, because things that I think are fun are not things you think are fun, but that's okay. I mean, it's not TikTok, but come on, it's like not that bad, right? So this one would be our base is v, our exponent is 4, and our argument is u. So this one's going to be log base u of v equals negative 14. And you'll see why we need to be able to do this very quickly, because this is how we solve so many log problems. So this would be base 2 of u equals v. This would be log base 8 of a equals b. And this would be y to the negative 8 equals x.